All right, so don't see anyone online quite yet, so I'll go use this time to kind of get it out, get some announcements out of the way, as well as answer some of the questions I've seen sent regarding WebAssign. So a few comments. If you have not gotten your lab kit yet, please shoot me an email by tomorrow so we can talk about what you can do in the meantime. Carolina Biological is kind of inconsistent in how they get things out. Some of you are getting stuff today, some of you may not get it next week. My kit was ordered for me a month ago and I still haven't got it. So again, talk with me, work with me. We'll see what we can do maybe in terms of extending deadlines. But again, if you don't send me an email, there's not much I can do on my end to help you out. Now, I've gotten several questions about the colligative properties homework. And so first I'm going to address some big common problems, and then we'll work through a specific problem regarding the homework. So the thing is that you're going to see a transition here between Chemistry 1 and Chemistry 2. Chemistry 1 is a much more qualitative course, and what I mean by that is that a lot of things we talked about in Chemistry 1 were facts. Okay, what's an s orbital, what's a p orbital, what's a d orbital, and particularly if you took Chemistry 1 at Wake Tech, you didn't really see calculations until you got into the last 2 units of the course. So when you talked about calorimetry, when you talked about concentrations and things like that. So because it was not a quantitative course, you could pick up bad habits and not know you were picking up bad habits. And one big problem is what's called intermediate rounding. So in Chemistry 1, typically you did maybe 1 or 2 steps in your calculations and that's it. And what you're going to see, particularly with this course, is that there are 3 or 4 or up to 5 tethered calculations. So the result from one calculation feeds to the next, which feeds the next to the feeds the next. If you are doing intermediate rounding, meaning that you're stopping at 3 sig figs, when you get done, you're going to start seeing your answer diverge from what's considered the correct answer. So WebAssign has some tolerances built into it, but these are very tight tolerances because particularly with later problems, it's very easy to get the right answer for the wrong reason, and so these tight tolerances have to be built in. But the first thing here is that do not do intermediate rounding. What you need to be doing when you do these calculations is carry all your decimal points. Now, a lot of you are still using handheld calculators. That's fine for now, but you're going to see about test 3, test 4, you probably want to start switching to Excel. Now, the tests are designed in such a way that they can be done with a calculator, but the nice thing about Excel is Excel is going to carry 100 decimal points worth of precision. You're not going to get rounding errors in that case, but your calculator typically only carries about 10 to 20 decimal points of precision from what I've been able to see with the TI-34s and all the other knockoffs. That's not enough for this course. So, big one, don't do intermediate rounding. Second, you keep seeing this comment about use 1 decimal points in the atomic weights in the problems. There's a reason for this, and this goes back to the intermediate rounding. Depending on how many decimal points you carry out in your atomic mass, you're going to find that you get a slightly different answer, and this is also an intermediate rounding effect. So the 1 decimal point in the atomic weight means that if you're working with something like oxygen is 15.998 AMUs. Well, if you're working with 5 significant figures here, if we drop down to 4, we get this. If we drop down to 3, we get this. These are considered the same within the precision, so the 16.0 within its precision does sweep that. But you're going to get slightly different answers. So for the atomic weights, to make sure that you're not going to get this issue of intermediate rounding, I'm telling you on the homework, stick to 1 decimal point. Now, that does not mean 1 decimal point your final answer. It just means that when you do your atomic weights, only use 1 decimal point of accuracy, and this will keep you from kind of getting those intermediate rounding errors. Now, third thing, and I see this a lot, WebAssign here is going to care about your significant figures. So again, you need to go back. This is more of a Chemistry 1 concept. I do have a lot of videos on this. Go relearn your rules for significant figures. Typically, the significant figures are going to come from the problem statement itself. So if you see something like 1.5 liters, that's probably telling you your final answer needs to be to 2 significant figures. But if you see something like 15.00 mLs, that's 4 significant figures, so your final answer is going to finish with 4 significant figures. Now, there are 2 exceptions to this. First exception are logarithms and exponentials. The reason these are exceptions is that we do not have rules on how logarithms and exponentials work in terms of their errors. So the rule of thumb that we use is 3 significant figures. And that rule of thumb comes from slide rules, actually. The old slide rules had 3 significant figures of precision, so if you did an exponential or logarithmic calculation, that's all you could get. The second are square roots. And we're going to see this when we start working with acids and bases. If you have a concentration and you have to take a square root to get that concentration, you're going to have to deal with three significant figures. So there will come a point in this course where we start dealing with three sig figs, not because that's correct, it's because we don't have rules. But for these homework problems, you're going to see that with a lot of these homeworks, it's not just targeting the concepts, it's targeting concepts from Chemistry 1 as well. So do you still know how to do significant figures? Do you still know how to do atomic weights? Do you still know how to do algebraic rearrangements? Can you convert between milliliters and liters, kilograms and grams? Just to make sure you're still there. This test will be the easiest test you take this week. And it's kind of by design. Actually, in a normal seated summer course, today would have been your first exam. So we knock everything out of the first 4 days because this is the very qualitative Chem 1-like material. As some of you probably saw with the discussion board today, this is a much more involved topic. So chemical reaction mechanisms, this is something you probably have not seen before, and it's a lot more involved. So I try to get the light stuff out of the way early so we can dedicate more time to the more complicated problems. Now in terms of an actual homework problem, if you haven't done so already, all the homework is found under the web assigned links. So I'm going to bring up, I'll share my desktop with you. Let's bring up this first homework problem. And I think this is one of the intermediate problems. The difference between the intermediates and the easy is with the intermediates, you're going to be required to actually do some calculations. For the easy ones, it gives you the molality, and that's just making sure you know the formula delta T equals KIM. So we have 1.93 grams of C3H7OH, probably 1 propanol, dissolved in 0.25 kilograms of cyclohexane. And here we've got I is 1.00. Okay. So, with this type of problem, a few things to note. There are lots of tables of Van't Hoff factors, so that's what your I is here. There's actually multiple ways to get at them on the course website, and I'll show you really quick. So if you log in, so the course website, under lessons, test 1, you're going to find these study packets. These are more meant for the seated courses, but I provide them to you just so you have the additional practice. You will find at the front of that a list of Van't Hoff factors, KF, KBs, and a list of vapor pressures. I don't tell you to go to this because it's also available in your book. Someone pointed out that the table number has changed, but it is in your book. If you just Google it, you're going to find tables of Van't Hoff factors. So the Van't Hoff factor here is going to be an actual one. It's not a theoretical. So the notes talk about where the theoretical Van't Hoff comes from. Nothing ever equals its theoretical Van't Hoff. This is purely an engineering idea. So engineers correlate it, and what they correlate it is that things like HCl have 1.9. But anyway, on the test, you're going to need to use the Van't Hoff factors. You can Google them, you can use the book, or you can use the study packets which have them on the front. Anyway, for this problem, it's asking you what's the temperature change. So we've got our 1.93 grams C3H7OH. First thing we need to do is convert to moles. So I'm going to bring up Excel on my end. And the atomic weight here, or molecular weight of the compound, just a minute. It's going to be 60.0 grams of C3H7OH for every mole C3H7OH. So if I take my 1.93 and divide by that number, I'm going to get 0.03217, but I'm going to keep trailing all these decimal points off to the side. If I were to report the answer at this point, I would be reporting to the 3 significant figures here, but again, this is an intermediate step in my calculations. Next step is I need to find the molality. So my 0.032167 moles C3H7OH divided by my 0.250 kilograms of solvent, in this case the cyclohexane, gives me 0.128667 trailing onwards for my molality. Now I'm ready to apply to the delta T equals KIM formula. So I have delta T equals K. Now this is asking specifically for the boiling point change. Bring up my tables. The Kb for cyclohexane here is 2.79. You're given I is 1.00, and your molality here is the 0.128667. So when you work this all out, you're going to get 0.35898 trailing on. So at this point, you're now ready to actually enter your answers into WebAssign. So if we go back, I'll bring it back up, we look at the problem. We've got 3 sig figs here for the 1.93, and we've got the 3 sig figs here for the 0.250. So that tells us that we need to have 3 significant figures in our final answer. So these 3 are the significant ones. We're going to need to round this up. So the answer here is 0.359 degrees C. And you can see that in the answer key. So bring it back up. It says 0.359, but in the event that you forgot to round here or you questioned what the rounding was, you've got the 0.358 and the 0.360 as acceptable answers as well. And that's really those types of colligative properties. Osmotic pressure is going to work the same way. With osmotic pressure, you've got pi equals trim. Big M here is molality. The molality is going to kind of follow the same line of reasoning. Carry all your numbers in your calculations. Now, the R here needs to be the 8.314 kiloliters kilopascals per mole Kelvin. Some of you were taught the gas constants for atmospheres. Don't use that gas constant. One, it is not an actual unit of pressure. Atmospheres is not a force per unit area. But the big reason you're not going to use it here is molality is moles per liter. So the liters are not going to cancel out in the gas constant if you use the gas constant for atmospheres times liters. I'm sorry. It will. The reason you don't need to do it is because the key is programmed in kilopascals. So if you try to use R in terms of atmospheres, it's going to give you wrong answers. We're going to work in metric units. So metric unit of pressure is a kilopascal or a pascal, not atmospheres. Now, let's see what the other question I had about. All right, so another question I was asked about was theoretical densities. So I'm going to bring up the notes for that really quick. Of course. Sorry, this laptop's a little slow. So if you go into the course website underneath Lessons Ribbons, you're going to find this first lecture on colligative properties. And there are a list of 3 formulas for a primitive crystal structure, for a BCC structure, and for an FCC structure. MW here is the molecular weight of whatever the atom is. Na here is Avogadro's number, the 6.02 times 10 to the 23rd. The R here is your atomic radius in nanometers. That's why you've got it up here. And those are really it. So these types of problems are far more plug and chug. The major issue students have with these problems is simply getting it into their calculator correctly. So for any of these, let's say we take the formula for a primitive cell. The packet density is 1 over 2r cubed. We have a conversion factor. When you enter this into the calculator, put parentheses around everything. So make sure this is in parentheses, this is in parentheses, this is in parentheses, and this is in parentheses. Now, I do try to kind of give you a range to look for, so typically 1 to 10 grams per centimeter cubed is what you should be expecting for the theoretical packing densities. It can get a little higher. I think 20 is the maximum, but that's really pushing it. The reason I give this to you is that 99% of the problems I see with the packing density problems are more related to you got a super tiny value or you got a super large value, and that's because one of these powers of 10 was not correctly bracketed out in terms of parentheses. Now, in terms of an actual homework problem, if we look at the first problem, so we have boromirium, which has atomic weight of 35.3 grams per mole. So our molecular atomic weight here is 35.3. We've got an atomic radius of 0.131 nanometers. And this is an FCC crystal structure. So we have all the information we need here to figure out packing density. So if we go to the formulas, one, for an FCC, it's 4 over 8 r squared raised to the 3/2 power times 10 to the 7th over 1 to the 3rd power times the molecular weight over Avogadro's number. So let's do this in Excel just to make it a little bit easier to see. Molecular weight in this case, 35.3. Radius, 0.131. To figure out our density, we've got 1 divided by 8 times the radius squared to the 3/2 power times 10 to the 7th to the 3rd power is just 10 to the 21 times our molecular weight, 35.3, divided by Avogadro's number, which is 6.02, 10 to the 23rd. Let me do that the way you would do it in a calculator. So this is the actual formula you're working with. You hit enter. What on earth? I gotta figure out where I put it in wrong. Definitely know the key is right, so this is an error on my end in terms of the calculation. Because I forgot the 4 that's on top right there. There you go. It's the joy of working with Excel is that you can just take your old formula and correct it. So I get 4.61, and if I go back to the answer key, it'll accept 4.61, 4.60, 4.62. So with all these packing density questions, basically it boils down to, can you properly put the formula into your calculator? As you can see with what I just did in Excel, sometimes you make a little mistake. Now I'm going to start pushing you harder and harder to use Excel. One, it's just practical. Excel is what's used in the real world. No one uses a calculator in the real world. It's the equivalent of the number line from first grade. The second is that if you do make these types of mistakes, they're far easier to diagnose and far quicker to correct. All right, so let's see if I've got any other questions. Now I've also just gotten requests about doing hard concentrations. So let me bring one of those up for you. So I think that's it for my emailed questions. So let's start with the first one. Let's say you have a 0.3.9 mole sodium plus solution, and you want to go to weight fraction here, grams per gram, or mass fraction. How do you do this? So this is a very... So I wanted to assuage your concerns. There is a question about this on the exam. It is one question, and it's a multiple choice question. This tends to be the hardest thing to understand, but it's not really super integral to chemistry too. So it's one of those unfortunate things. It's hard and oddly not as important as you think. But how do you do it? Well, there's actually a handful of steps you have to follow. First thing you need to do is write out the units of what you're given. So we've got molality. Molality here is going to have units of moles of solute per kilogram of solvent. So the bracket error here means units of. Second, we need to write the units of what we're interested in. So we want to get to grams per gram. So this has units of grams of solute per grams of solution. Third thing, we're going to make an assumption. And we're going to make the assumption purely for a practical reason. Concentration does not change depending on how much we have. So think about it this way. Density of water is 1 gram per milliliter. That's not going to change if you have a gallon of water, if you have an ocean of water, if you have a thimble of water. It's all the same concentration. The same thing is going to be true when we're working with these types of concentrations. It doesn't matter how much we have. So what we're going to assume is that we have 1 of whatever is in the denominator of what we're given. So if we're given molality, we're going to assume 1 kilogram of solvent. Now, this is not the assumption we're going to make every time. This is not a do this every time scenario. It depends on what you're given. If you're given molarity, that's units of moles of solute per liter of solution, so you would assume 1 liter of solution. In this weight fraction, if you're given that, you would assume 1 gram of solution, and we'll talk about why in just a minute. Now, from here, you have everything you need to figure out the new concentration, because there's 3 formulas. The first is that the moles of solute times its molecular weight gives us our grams of solute. Our grams of solution is just our grams of solute plus our grams of solvent, and that the density of our solution is just the grams of solution over the volume of solution. Now, what are we going to do? Well, we assumed we have 1 kilogram of solvent. So if we take our molality and multiply by the 1 kilogram, we're going to get 3.90 moles of Na+. And that's why we made the assumption 1. It makes the math really easy. So if I have 1 kilogram of solvent, that means I have 3.9 moles of Na+. What I need to know is that in this 1 kilogram of solvent, how many grams of solute do I have, and how many grams of solution I have. Well, if I have 3.9 moles of sodium, I can plug out there, sodium weighs 23.1, and that will give me my grams of solute. I assumed I had 1 kilogram of solvent, which means that I have 1,000 grams of solvent. So let me do that calculation real quick. 3.9. 23.1. So if I have that many moles of sodium plus, I have 90.09 grams of sodium plus, and when I add them together, I get 1,090.09 grams of solution. Now I can just take that information and plug it back into what I'm getting for. Grams of solute in this 1 kilogram, I'm going to have 90.09 grams of solute. In terms of my solution, I have 1,090.09. So if I work that out, I will get G over G equals 0.0826. Grams per gram. And if I take a look at the answer key, that's what I get, 0.0824. Looks like I made a, oh, because sodium doesn't weigh that, it weighs 23.0. Yeah, 823. Sorry about that. And again, it accepts within a small range what your answer is. And that's pretty much how you solve all those types of problems. Basically, you're going to take the same approach. Write out the units of what you're given, write out the units of what you want to get to, assume 1 of whatever you're given. If you're given molality, assume 1 kilogram of solvent. If you're given molarity, assume 1 liter of solution. If you're given weight fraction, assume 1 gram of solution. Use these 3 formulas to backtrack out any information you don't have in this whatever unit you're trying to get to. And then once you figure out how much you have of each of the units you're trying to get to in the final concentration, just plug them in, get a number, and that's what you're going to put back in. And again, this just kind of works underneath the assumption that the concentration is not going to change depending on how much we have, and that's a pretty valid assumption. Any other questions? Apparently not, because I don't have anyone watching. So, few comments about tests in general and the resources available to you in general. First of all, there is a reason I count WebAssign for only 2.5% for your homework. I don't want you to freak out if you're getting answers wrong. I give you 5 submissions. That's a lot of submissions. The only exception to this are multiple choice, kind of for obvious reasons. So with the homework, feel free to do poorly, but don't burn through your submissions. You probably noticed that you get 5 submissions per question and 5 questions. I do not believe in lengthy homework sets, because if you can do it on the first try, you can probably do it on the 50th try. I don't want to get you inundated with having to do lots and lots and lots of homework. Don't waste your submissions. If you get a submission 2 or 3, send me an email. Generally on my end, I can kind of figure out what's going on. Those of you who have already emailed can probably attest to the fact that I'll tell you if your answer is close and just tell you what it is, acknowledging that it's probably a rounding error. If you want more practice, there are practice packets on the course website. I would recommend downloading those because they're going to be far more representative of the test than the homework. The homework is a good selection of 90% of what the exam is going to be. I don't believe in gotcha tests. It's clear, I try to make it clear what I expect you to be able to do on the exam to get the credit. Now, for the exam itself, when you take the exam, there is the exam and there is the work. The work is going to be 90% of the free response sections. So if you just submit an exam and you don't submit any work to go with it, you're only going to get like whatever points you get for getting the answers right if you get them right. I want you to submit the work for two reasons. One, it's a test cheating. It's a way to catch people who are cheating on tests, because if I see your work is exactly the same, usually tip off you probably collaborated. The other is that I want to understand where you're not getting concepts, because I get a lot more feedback from a free response question than I do get from a multiple choice question. Multiple choice questions tend to basically be knowledge-based stuff, and this is going to be more reflected in those packets than it is in the web assign. The web assign is more meant for calculations and some concepts, but concepts that are better talked about. I don't really want to grade essays on web assign, so the packets are there to kind of give you a feel for what type of information would be asked in terms of like a qualitative question. Now, again, the packets provide for your solutions. You've got videos. You've got all week to take the exam. Please don't wait until the last minute to take the exam. Go ahead and knock it out of the way, because today would have been the first day we took the test. The rest of this week would be reactions. Now, in terms of the discussion boards, you need to do the discussion boards. They are attendance in an online course. So your labs, your 2 labs are 1 day of attendance, and your in-class, your discussion boards are the other days of attendance. If you're not doing discussion boards, it's going to look like you're not attending course, and if you miss 10 courses, you're going to be dropped from the course. So go ahead, try to keep up with the discussion boards. I'm going to reserve doing attendance until the following week if I can. The reason for this is that it will give you all week to do the discussion board. The discussion board due dates are more meant to kind of give you a feel for where you should be in the course. So by this point, you should be able to answer this type of question. By this point, you should be able to answer this type of question. And it's going to focus more on the higher end concepts. It's not going to focus so much on like qualitative information, because like that's easy. You can learn that on your own. It kind of gives me fodder for these live stream discussions. So you will have all that time, 1 week, to do the discussion boards for that week. Go ahead and use that time. I am not going to take off points because you do a discussion board late. You are going to lose points. You're going to get zeros if the attendance period has come and gone. But the discussion boards there are more to kind of make sure that you're understanding the material and give me feedback as an instructor. So hopefully you're kind of getting a feel now for what's expected of the course. Some of you did comment the homework date moved. I tried to take this weekend off, but a lot of you saw I respond to emails. I had limited email access, so I didn't update the announcement in Blackboard. I'm not going to. Y'all know that it's due tomorrow. The reason the extension was granted, we had students that were allowed into the course Wednesday and Thursday of last week by the school because the course filled and then it didn't fill. It seemed really unfair for the people who started the course Wednesday or Thursday to do all the homework on their own by yesterday, and with me being on a long vacation. So that's why the due date was moved 2 days. That's not going to happen again for the rest of the semester. Nobody's being added or dropped, and we're just not going to do that. But again, I didn't send an announcement out because I had limited email contact this weekend. I was actually trying to take a vacation. So I did try to respond to your emails, but that discussion board about being due, no, you can see on WebAssign when it's due, and that's going to be the only discussion board. That's going to be the only homework that really moves this semester. So other than that, unless I'm really going to see any more questions in the next few minutes, I will probably sign off for the live streams. Oh wait, how many discussion board questions will we have due per week? Oh, I'll backtrack. So someone's just asked, will the recording be available after the live stream is over? Yes. Forgot to set it up Thursday before I took off last week, but what I'm going to do is I'm going to create a playlist in YouTube that will be available under the lessons ribbons. You can go to that. You can look through all the previous live streams. I'm not going to take them down. As far as discussion boards, there's going to be 2 due per week. I think that's a reasonable pace, particularly ones that require calculations. I don't want you to be overwhelmed with the discussion boards. So every week, you're going to have 2 discussion boards and 2 labs. And that's going to fill in your 4 days of attendance for the week. Now the labs are due earlier. I think they're due Thursday nights. Two reasons for this. One, to motivate you to go ahead and get them out of the way. The second is that the labs can actually be done in advance. This isn't true of the discussion boards. Discussion boards open up when the previous discussion board due date has passed. So if you are really feeling motivated, you can go out ahead and knock out all the labs for the semester. All the labs are visible right now under WebAssign. The idea is that if you know you're going to have a busy week, go ahead and do the labs, get them out of the way. The only ones that are restricted, you've got an ethics assignment that's due, and you've also got the oral reports. Those are date restricted. When you see the material, you'll see why. It's mostly because these are kind of meant to be candid responses, and I don't want you kind of like flavoring people's ideas. The other with the orals is just to give other people time to write them. But again, to go back, discussion boards just 2 per week, and you're going to see this every week. The only exception here is going to be the final exam day. There's no discussion board. Attendance for that day is counted based on whether or not you took the final exam. But I think that's kind of fair that I'm not going to give you a discussion board the last day of class. For those of you curious, also the live streams I had going back into the spring are also available to you on the course website. So if you're curious, if you're not getting a question answered in these live streams, we didn't start until I think test 4 for the live streams in the spring. So it's really only the back 40% of the material is covered on those live streams, but you can go back to read those as well. You can definitely tell towards the end of the semester, students were kind of getting comfortable, so those live streams get shorter and shorter. But yeah, you're going to have these live streams as well as the previous live streams to go off of. Plus the videos that are linked through the playlists, plus any emails you might have. They do count towards the homework. So homeworks on WebAssign are what the point values are determined by the number of questions. And then your discussion boards are 10 points added up to them. So at the end of the semester, to calculate your homework grade, I add up all the points that you got and divide by the total number of points that were there. So the discussion boards are a really good way to boost your homework grade. So your 8-week course, that's 16 discussion boards, that's 160 points. I think normally there's 450 points on the WebAssigns. I let you go back and correct your WebAssign, your discussion board questions. So if you go back and say, okay, I figured it out, here's my new answer, I'll give you the points back. The discussion boards are not meant to be punitive. They're meant to kind of get you engaged in the course. So they also count for homework, and they are 10 points on top of the additional homework points that you're getting. So I would say it's probably going to roughly count for 20% of your homework grade when you finish. Right, you're very welcome, Michaela. Vesper theory will not be on the tests. I teach functional groups. That's unique to me right now. It's kind of catching on with a lot of the other chemistry instructors. Originally, the way Chem 2 was taught was that we would teach you Vesper to explain intermolecular forces. And I got particularly frustrated because it seemed like students were not getting it. And it's weird because you'll watch an experienced chemist talk about intermolecular forces and like they were just rattling them off. And yet a Chem 2 student would look at us in complete disbelief because they didn't know what was there, they were guessing. And what I put together was that we as chemists don't really do Lewis theory. What we do is we do organic chemistry, which is simplified Lewis theory. So chemists, when they want to know what intermolecular forces are there, they do VSEPR. Oh, well, they don't do VSEPR. They do functional groups, and they can tell from the functional group immediately what the intermolecular forces are, what the reactivity is, what the name of the compound is. It's a lot of information tied into that little functional group. Lewis theory and VSEPR will get you to the point that basically if you do Lewis theory and VSEPR a lot, you'll start seeing functional groups pop up. Like you'll start saying, oh, this is what I always get when I have this type of material. But again, you're kind of seeing this transition from the way we've traditionally taught Chem 2, where it was draw the Lewis structure with VSEPR. Now that you've drawn and identified the intermolecular forces, to me saying, okay, look at the molecule and tell me what functional groups are there. And based on those functional groups, what intermolecular forces are there. And from there, you can figure out what the strongest intermolecular forces are. But you will not be required to draw a Lewis structure. You're not going to be required to name geometries or anything like that. I found it's kind of a lot of information that ultimately doesn't get you to the conclusions you want anyway. Functional groups are a far more efficient way of doing this. Although I probably should bring that up. So I have seen a common misconception, and this is more of an artifact of how we say things in chemistry. So there are alcohol molecules, and then there are alcohol functional groups. Now, all alcohol molecules contain an alcohol functional group. That's what makes them alcohols. But an alcohol functional group is not an alcohol molecule. So if we look at something like methanol, this is our alcohol functional group. But the alcohol molecule itself also contains two alkyl functional groups. So an alcohol molecule will contain both dispersion forces as well as hydrogen bonding, but an alcohol functional group only has the hydrogen bonding interaction. Now, this is where functional groups are super useful for rapidly figuring out intermolecular forces. So if I write out CH3, CH2, OH, I automatically know that this is alkyl, this is alcohol. That's the hydrogen bonding end, that's the dispersion end. If I ask you, how do these molecules line up in solution? Well, hydrogen bonding is going to want to align with hydrogen bonding, and alcohol is going to want to align with alcohol. So when these things are in solution, they typically line up like this. They try to put their alcohol groups close together because they have the same intermolecular forces, and they try to stick the alkyl groups together because they have the same intermolecular forces. That is not as apparent from this. So if I just told you to draw the VSEPR Lewis structure, you could draw it, but where the intermolecular forces are and what binds to what's not so obvious. Jumping to these functional groups also have their own geometries. So we know that something that is CH3 or CH2, we know these are both tetrahedral carbon atoms. We can quickly draw the Lewis structure because the functional group already has a geometry associated with it as well. It has connectivity associated with it as well, so it allows us to rapidly build the structure up. I know that was a long answer to your question, really wasn't your question. But again, I kind of saw this a lot on the discussion boards. And again, this is kind of it's just more of how we write things in chemistry. We say alcohol, and we try to blur the line between an alcohol and an alcohol functional group. In fact, I just did it. Try to blur the line between an alcohol molecule and an alcohol functional group. For the discussion boards, it was focusing exclusively on the functional groups. Again, an alcohol molecule is going to have lots of functional groups in it. We call it an alcohol molecule because the alcohol is the most important functional group. It dictates the chemistry, it dictates a lot of the behavior of it. But it's not the only functional group. In full disclosure, I didn't figure this out until I started teaching organic chemistry. And I figured it out because I could not figure out why our organic chemists were teaching these really weird ways of drawing Lewis structures that I don't understand how they draw them. But then it occurred to me they weren't actually drawing Lewis structures. In fact, if you read a lot of organic chemistry textbooks, Lewis structures are like the first paragraph of the first chapter, and then it's never mentioned again. Because this is really what they're doing. They're looking at functional groups. Now, what will be on the test is the impact of functional groups on physical properties like surface tension, vapor pressure, viscosity, things like that. It's hard to write a WebAssign for that just because it's pretty black or white what the answer is. As you increase... Oh, yeah, you're very welcome. Yeah, this is way simpler. I understand why organic chemists do it. I also understand why they're so bad at teaching Lewis theories. They haven't done it in years. But yeah, in terms of questions on the exam related to input forces, can you predict like the impact, like which molecule is going to have highest boiling point, lowest boiling point, things like that. And again, you're going to know pretty quick what the intermolecular forces are just by looking at this formula. This has got hydrogen bonding, so it's going to dictate what's going on. If I just had CH3CO CH3 versus 38 CH3OH, automatically know dipole is the strongest IMF here. Hydrogen bonding is the strongest IMF here. So I know which of these is bound to itself better. All right, I'll give you all a few more minutes in case you got questions. Big thing with this course, because we're doing what's called asynchronous, we're not physically meeting one-to-one. The discussion boards are a good time for me to get a feel for what you're not understanding, and these live streams are as well. So in response to what I saw on the discussion boards, I have put together a video on the differences between functional groups of molecules and actual functional groups. It's in a backlog of about 30 videos I need to process right now. But again, you're going to have to give me feedback in this course because generally with the student classroom, I get the feedback in real time. We're going to have to do this through asynchronous means. You doing discussion boards, you doing the live chats, you sending emails gives me a feel for what needs to be covered in these live streams. I am not going to lecture in the live streams. You don't want to sit through an hour-long video to listen to me talk about wait for like 3 minutes of useful information. I have my lecture video. I have my online videos for that. So again, these are more meant for you to do like kind of Q&A sessions. If you can't make the Q&A sessions, send me an email. You saw at the beginning of this video, I will answer emails and say, oh, somebody had a question about this. Let's talk about this. These are meant for you, and these are meant to give you feedback. In terms of office hours, I don't know if anyone has asked. I am not a fan of stream. I think I actually talked about my first video. I'm not a fan of streaming office hours. As you can kind of see with this video, I kind of came in with some questions. Most instructors I've talked to, they get like 2 questions, so you spend an hour watching me work on my computer. So live office hours, I formally don't have any. These are technically the office hours for you, but as a lot of you are seeing when you send me emails, if I'm online, I will try to respond to you. Not so much on the weekends. I do want a work-life balance, but yeah, I do also, particularly with this weekend, I was not going to respond to emails, but I acknowledge that your test is this week. So I try to get back to you as soon as I can on your emails. please give me feedback, because this is the only way we're going to kind of keep this course helpful for you. Oh, before I forget, you see that you're going to see this comment on the test. Until you see your work graded, and until I see your work, I'm not going to go over your exam. Do not worry about the points you get when you first submit your test. I have to put an answer key into Blackboard for your test. It doesn't understand scientific notation, so if you submit your test and you do poorly on it, wait until I've graded your work before you ask for points back, because when you get your test back, you're going to see what you lost points on. Generally speaking, it's going to be awful for the free response. So if you put something like 0.0393 and the answer was 3.93 to the negative 2, it's going to mark you wrong even though you had the right answer. So again, wait until you see your work graded. There is just an arbitrarily 1 point put in for your work. It doesn't count towards anything. It's just so I can see which exams have been graded and you can see that I've graded it. At that point, go back through. The key should be visible to you. If not, it'll be visible after the exam date is over with. But that's more when you're going to sit back and see if you actually lost points. But it's not uncommon to submit a test through Blackboard and you get like a 40. And it's because the formatting of your answer is slightly different than the formatting of its answer. It's even more picky than WebAssign. But you have to give me time to go back through and grade them. Like once you submit your test, I'm not waiting for you to submit your test. In fact, I'm going to go grade discussion boards after this. Again, wait for your work to be graded. Once it's graded, if you still see a low score, let me know. We can talk about what questions you missed. But again, it's going to give you a bad score. I've had very few students take their exam and they got the 90 on the first try. All right, I'm not seeing much feedback on this end, so we're going to have a live stream tomorrow. The goal here was to keep the Monday and Wednesday live streams at the same time, the Tuesday, Thursday, so there is some pattern and regularity. They're not at a different time each day of the week. Monday, Wednesday, it's going to be 12:30 to 1:30, I think. I don't know. You'll see. And then we're going to have the same time, 10:30 to 11 Thursdays, Tuesdays, and Thursdays. I will see you, hopefully several more of you tomorrow. And again, please email me your questions in advance so I can go ahead and start answering them off the bat, so you can just watch the video when you get the chance. And yeah, see y'all later.